Hi viewers, welcome to the next section of the course, Life of a Thread. In this section, we will understand the concepts of different states of a thread and the best practices when it comes to starting your own threads. Then we will discover how we can make our lives easier when it comes to working with loads of threads. Finally, we will be looking at how we can end threads. Let us begin with the first video of the section, Threads in Python. In this video, we'll take a look at thread state explained with a flowchart and a working example. Then we will discover the different types of threads. Let's begin with Python's thread class definition, which can be found in threading.py file. This class definition for the thread class, and it has a constructor function which looks something like this. The constructor takes in 5 real arguments, which are defined within that class definition. Group. This is a special parameter which is reserved for a future extension. Target is the callable object to be invoked by the run method. If not passed, this will default to none and nothing will be started. Name is the thread name. Next is args. This is the argument tuple for target invocation. It defaults to be null. Quargs is a dictionary of keyword arguments to invoke the base class constructor. Thread state. Threads can exist in 5 distinct states: running, not running, runnable, starting, and ended. When we create a thread, we have typically not allocated any resources towards this thread as of yet. It exists in no state, as it hasn't been initialized, and it can only be started or stopped. Let's take a quick look at these 5 states. This diagram represents the 5 different states that a thread can be in, as well as the possible transitions from one state to another. New thread. In the new thread state, our thread hasn't started, and it hasn't been allocated resources. It is merely an instance of an object. Then, in the runnable state, the thread is waiting to run. It has all the resources it needs in order to proceed, and the only thing holding it back is the task scheduler having not scheduled it to run. Next state is running. In this state, the thread makes progress. It executes whatever task it's meant to and has been chosen by the task scheduler to run. From this state, our thread can go into either a dead state if we choose to kill it, or it could go into a not running state. In the not running state, the thread has been paused in some way. This could be caused by a number of reasons, such as when waiting for the response of a long-running I/O request, or it could be deliberately blocked until another thread has completed its execution. The final state is dead. A thread can reach this state through one of 2 ways. It can, much like us, die of natural causes or be killed unnaturally. The latter poses a significant risk to the murderer, but we'll go into these risks in detail in the ending a thread section of this section. Next is Python example of thread state. So, now that we know the various states that our threads can be in, how does this translate into our Python programs? For that, we will create a new document and name it as threadlifecycle.py. Paste this block of code. Let's look at the code. Here, we define a function, threadWorker, which will be the invocation target of the thread that we will create. All that this threadWorker function does is to print out its current state and then sleep for 10 seconds. After we've defined threadWorker, we then go on to create a new thread object in this line. At this point in time, our thread object is currently in the new thread state and hasn't yet been allocated any system resources that it needs to run. This only happens when we go on to call this function. At this point, our thread is allocated with all of its resources, and the thread's run function is called. The thread now enters the runnable state. It goes on to print out its own state, and then proceeds to block for 10 seconds. During the 10 seconds that this thread sleeps, the thread is considered to be in the not running state, and other threads will be scheduled to run over this thread. Finally, once the 10-second period has elapsed, our thread is considered to have ended and be in the dead state. It no longer needs any of the resources that it was allocated, and it will be cleaned up by the garbage collector. and it prints the dead state. Let's look at different types of threads. There are two types of threads, such as Posix Threads and Windows Threads. When we talk about Posix Threads, we are talking about threads that are implemented to follow the IEEE Posix 1003.1c standard. When we talk about Windows Threads, we are talking about the standard that Microsoft has chosen to implement their own low-level threads against other threads. That's all about threads in Python.